Here's a lesson on the fundamental theorem of algebra. This table shows you the statements that are equivalent. A real number r is a root of a polynomial equation when you set the polynomial equal to 0. If you evaluate the root, you should get 0. R is an x-intercept, so if you were to graph the polynomial, that would be the x-intercept. You can write the 0 in factored form. It would be x minus r. When you divide the rule by the remainder will be 0, and then r is a 0 of the function. So what we're going to do is we're going to write the function given the roots. So example 1 says we have 3 roots. We have -1, -1, and +2. So if we were to graph this polynomial, these would be the x-intercepts. So what we're going to do is we're going to write the polynomial in factored form. So if we go back up to here, how we write the roots in factored form, it's always going to be x minus the root. So f of x equals, so here's my first root, so it'll be x minus -1. And then my second root is also the same, x minus -1. And then the last one, x minus 2. And then what we want to do is we want to simplify it to standard form. So we notice that there is a subtraction and a negative, so we change that to an addition symbol. So it'll be x plus 1. And then x plus 1. And then x minus 2. Now I want to get into standard form. So we're going to first distribute the first 2 binomials. So to do that, we have 2 binomials. We're going to FOIL them. So first, outside, inside, and last. Then we're going to go ahead and simplify that green bracket. Notice there's like terms with the 2 x's there. So we get x squared plus 2x plus 1. So there's the first parentheses. And then we have the second parentheses, x minus 2. Now we want to distribute again. So we're going to multiply. X squared times x is x cubed. X squared times -2, -2x squared. Then 2x times x, 2x squared. 2x times -2, -4x. 1 times x, 1x. 1 times -2, -2. And then we combine any like terms. So we have like terms here and there. Notice that -2x squared and positive 2x squared will cancel out. Combine -4x plus 1x is -3x, and then minus 2. So what we end up with is a cubic function, and it's a cubic trinomial. When we have complex roots, they occur in pairs. So they are going to be, if you have a complex root of a plus bi, then you're going to have the pair, the conjugate, a minus bi. So here's an example. We have 3 roots. We have a real number of 2, an imaginary root of I, and then its pair, -i. So we're going to write this first in factored form. So just like before, in the pink here, we have to write it as x minus the root. So the first root is 2, so it's x minus 2. The second root is I, so x minus I. And then the third root is negative I, so x minus negative I. And then we're going to simplify. So notice that negative negative just turns to a plus symbol. Now we need to multiply the polynomials together. So I'm just going to write the imaginary roots factors first, and then the real root at the end. When we multiply, we're going to multiply the complex factors together. So we'll do first, outside, inside, last again. So first, outside, inside, and last. And we get x squared, ix, negative ix, and negative I squared. And then we have the x minus 2 at the end. Notice we have like terms. We have positive ix and negative ix. They cancel out. And then in an earlier chapter, we remember that I squared is going to always be replaced with negative 1. So here's our I squared. That's going to be replaced with negative 1. So we replace the I squared with negative 1, and then we have x minus 2. Now again, we have a negative negative, so that's going to turn into a plus symbol. Now we multiply again by the distributive property, so we're going to FOIL, so first, outside, inside, last. So we get x cubed minus 2x squared plus 1x minus 2. So we end up with a cubic polynomial with 4 terms. Example 3, we have 2 roots given. We have a real root of negative 4, and then we have a complex root of 3i. So earlier here on this slide shows yet that we have to identify that they occur in pairs, so we have to do the conjugate. So the conjugate of positive 3i would be negative 3i. So there's our 3 roots. So I'll write this in factored form. So the real root of x minus negative 4 in factored form, and then x minus 3i, and then x minus negative 3i. Now the subtraction of negatives turns to an addition symbol. And then I'm going to write my complex factors first. Now we'll go ahead and FOIL the 2 factors of x minus 3i and x plus 3i. So first, outside, inside, last. So there's the foiling, and then we have x plus 4 on the end. Now again, we have a pair of like terms. The 3ix and the negative 3x will cancel out, and then we have another I squared. So that I squared gets replaced with negative 1. So when I replace this with a -1, what that does, it just changes the 9, makes it a +9. All right, now we're going to go ahead and FOIL again. So we'll do first x to the third outside 4x squared inside 9x last 36. So our function is a cubic polynomial with 4 terms.